everybody. I'm Roman Rodriguez and doing chapter 3 Kinematics of linear equation, physics of grade 9 and 10. Okay, this is lesson number 3 and we have completed up to question number 3.8. So I'll be doing 3 more questions now on the same chapter, chapter 3, on page 44 and 45. Okay, 3.9. Let me just write down the data first, question 3.9. It says here a car starting from rest attains a velocity of 20 meter per second. It starts from rest, that means its initial velocity is 0. It attains a velocity of 20 meter per second, so final velocity is 20 meter per second. It takes 5 seconds, so time is 5 seconds. You have to find the distance covered by the car. Distance is divided by s, so we need to find this. So we'll be using these formulas, and we know Vf is equals to Vi plus 80. This in case we need to find the acceleration, and then distance, and s is equals to Vit plus half 80 squared. We also have distance over here in this formula 2as is equals to Vf squared minus Vi squared. Now in both the formula we need to know the acceleration. So first we will find the acceleration. So we'll use the first equation of motion, which is Vf is equals to Vi plus 80. Okay, solution. Final velocity is 20, initial velocity we have is 0, acceleration we do not know, but we know time is 5. So we have, let's say 5a is equals to 20, move 5 on the other side, a is equals to 20 upon 5. So our acceleration is 4 meter per second squared. Now, we know the acceleration. Now we can apply any one of these formula. Let's say the first formula, s is equals to the second equation of motion. S is equals to Vit plus half at squared. So distance is, we need to know. Initial velocity is 0, time is 5. Half acceleration we just found out is 4 meter per second squared. Time is 5. 0 multiplied by anything will give you 0. 2 will go to 4 2 times. 5 5 are 25. 25 2s are. 2 times 25 will give you 50. So 50 meters is the answer. Even if we apply the third equation of motion, that is 2as is equals to Vf squared minus Vi squared, we will get the same result. You could either use this formula, s is equals to Vit plus half 80 squared, or 2as is equals to Vf squared minus Vi plus 80. Vf squared minus Vi squared. 2 times acceleration is 4, distance is what we need to find out. Final velocity is 20, the whole square, minus initial velocity is 0, 0 squared will give you 0, 2 4s are 8, and 20 squared will give you 400. So s is equals to 400 divided by 8, 8 will go to 45 times 50 meters. So there you are. So whether you use this, 2s is equals to Vf squared minus Vi squared, or s is equals to Vit plus half 80 squared, you'll get the same answer, that is 50 meters. Right? Okay, let's move on to the next question, 3.10. Now in 3.10 it says a stone is dropped from a top of a tower. Now up to 3.9 we solved questions which were based on linear motion, which is moving horizontally, that is left to right or right to left, whatever it is. But now question number 3.10 onwards, there are questions on linear motion, moving top to down, you could say, or north to south, or whatever, up and down, vertically. Okay, this is horizontally, east to west, this is vertically, that is north to south, okay, or south to north. When you throw a body up vertically, or it is falling down, and this is east to west or west to east, you could say. Okay, stone is dropped from a top of a tower. When you drop an object from the top of a tower, remember that the initial velocity will always be 0. Okay, so and when it is thrown upward, when it reaches at the highest point, it halts over there, it stops, so the final velocity will be 0. Okay, and the same equation of motion, but now we will be replacing a with gravity, that is acceleration due to gravity g, and the distance we are not talking about moving horizontally, but we are talking about bodies moving vertically. So we will replace s with h. So now your equation of motion would be Vf, let me write it with another ink. So we can write Vf is equals to, Vf is equals to Vi plus, instead of A, Gt, and then instead of S we will replace it with H, height, h is equals to vit plus half gt squared, or 2gh is equals to vf squared minus vi squared. So we will be using these equations, this equation of motion now, okay, because we are talking about bodies moving vertically. So in 3.10 we have a stone dropped from the top of a car. So when any object which is falling from top, so remember I said vi is equals to 0, and the value of g is always taken as 10 meter per second square. It's approximately 10 meter per second square. Okay, in some books it's mentioned as 9.8 meter per second square. So we take it as 10 meter per second square for body moving downward. And the value of g will always be positive. And when a body is moving upward, when it is thrown up on top, then the final velocity over here would be 0. It will fall down over here with a certain velocity. We don't know what that is, okay, but depending on the height. But over here, but the value of g will always be constant, same. But when body moving vertically upward, final velocity will be 0, and it will be thrown with a certain velocity. So we don't know what the initial velocity is, x in meters per second. Okay, but remember, when body is moving against the gravity, so the value of g will be taken as negative 10 minus 10 meter per second square. You need to know this rule, okay? For a body is moving vertically upward or downward, okay? This is moving upward and this is downward. So let's continue with this problem. So here, a stone is dropped from the top of a tower, so initial velocity is 0. Let me do it over here. Initial velocity is 0, and it takes 5 seconds to hit the ground. Okay, to hit the ground it takes 5 seconds. The time is 5 seconds. Calculate the height of the tower. H is equals to how much, and the value of g is given to us. We need to take it as 10 meter per second square. Even if it's not given, you will take it as 10 meter per second square. So let's solve this. We will be using the first equation of motion over here for bodies moving vertically. So Vf is equals to Vi plus Gt. We can use Vi, since we are finding the height, so we use either this or this equation. Okay, so let's use the second equation. H is equals to, because we are not going to find the final velocity, H is equals to Vit plus half Gt squared. We need to know the height. Initial velocity is 0 times time is, it takes 5 seconds. So half g is 10 meter per second square. Acceleration due to gravity. Time is 5, the whole square. 0 multiplied by anything would give you 0. Plus 2 would go into 10 5 times. 5 5s are 25. 5 times 25 would give you 5 5 25, 5 to 10, 125 meters. This is your answer, the height of the tower. Okay, there you go. Now let's move on to the last question, 3.11. I'll just erase this. Okay. So it says here 3.11. Let me write down the data first. A boy throws a ball with a velocity of 20 meters per second. Now he's throwing it. He's throwing it in the upward direction. So initial velocity would be 20 meters per second. Okay, find the time elapsed between the throwing and catching the ball. Between throwing and catching, going up and then coming back to this ball. Okay, so he throws the ball up and then he catches it. So just make him stand somewhere at the center over here. Okay, right? He throws the ball up. Okay, and then he catches it down. So initial velocity is 20 meters per second. Okay, final velocity will be 0. Initial velocity is 20 meters per second. Okay, right. What are the information they have given us? Nothing. So when he is throwing the ball on top, it's moving against the gravity. So we write it as g. We take g as minus 10 meters per second squared. Let's find the time. So we can use the formula h. They have not given us the height. Find the time elapsed. No. So we will use the formula where height is unknown. So yes, Vf is equals to Vi plus Gt. So final velocity we don't know. Initial velocity is 20 plus when it is thrown on top. Sorry, final velocity will be 0, okay, because it stops over here. So at this time, so we are finding basically the time taken for it to reach this height, okay, the time taken. So final velocity is 0, initial velocity is 20, g is moving against gravity minus 10, and time is unknown. Let's move 20 over here. So 0 minus 20 will give you minus 20, minus 10t, minus minus will cancel. So you have time is equal to 2 seconds. So it takes 2 seconds for the ball to go on top. So the total time elapsed would be t1 plus t2. And if we consider this as t1, it will be equal to t2. So 2 seconds plus 2 seconds will give you 4 seconds. So this is the total time elapsed. Okay. So there you are. So I hope you have understood these questions. We'll be doing 2 more questions in the next lesson, and then we'll end this chapter. Thank you very much.